Hi everyone, how are you guys doing? So first of all, let me welcome you guys to the Unacademy JEE English. This, as you know, is a brand new channel by Unacademy, which is India's largest online learning platform for IIT JEE. And on this channel, all the concepts of physics, chemistry, and maths are being taught to you completely in English. This is the series that I host for class 11 students, and the topic that we are discussing right now is gravitation, and this is lecture number 6 of gravitation. Today we'll be talking about satellite motion. All right. So now, before we get started with today's discussion, let me introduce myself for those of you who might not know me yet. Okay, so my name is Rohit Dixit and I studied mechanical engineering from IIT Delhi. And for almost past 8 years, I've been teaching physics for the JEE Mains and Advanced examinations. I myself, as a student, was All India rank 447 and All India rank 192 in the two stages of the IIT JEE exams that I took. And I qualified at the NDC Stage 2 examination, and I was in the top 1% in the NACP as well. Now, I've already coached many students to top ranks in the IIT JEE exams, both mains and advanced in this in my teaching experience of offline setups. Offline I've been associated with some of the topmost institutes where I got the opportunity to guide a lot of students to top ranks and their dream colleges. Now is me trying to do the same here online with you guys. All right, so how can you guys make sure that you are also achieving your dream ranks and getting to your dream colleges? So one great way of adapting in this environment is to get yourselves the Unacademy subscription. This subscription will give you benefits like live classes where you get to interact with your educators. You also have live polls and leaderboards in these classrooms. You also have test series and analysis sessions on a regular basis, which keep you on your toes and keep you completely informed of your standing in the competition. And of course, you have live doubt clearing sessions. So these sessions will ensure that you have no doubts piled up. So for all the Unacademy Plus courses, every fourth session of the Unacademy of any Unacademy Plus course is supposed to be a live doubt clearing session. So where a student may ask any doubts that they have in the past three teaching sessions. It may be related to theory concepts and or it may even be related to problem solving. So with this subscription, with these chances, your doubts never get piled up and your studies carry forward, very smooth manner. All right. So along with all these benefits, Unacademy also provides you another great opportunity, which is to study from the. Hi AP, how are you? Hello to you. All right. So as I was saying, now along with this subscription, you have a great opportunity in front of yourself. Now you can study from the topmost educators from all across India from the comfort and safety of your home. So get the subscription and get benefit from all these features. Now, the first step towards utilizing these features is to install the Unacademy app. Now, the moment you install the Unacademy app, you already unlock for yourself a lot of free features. So, the Unacademy app has a lot of free courses. Okay, so you can enroll in these courses just after installing the Unacademy app. You don't even have to get the subscription. You can install the app and attend these free courses. Plus, you have something called special classes. All right. So these are free lectures that are taken by various, faculties on the Unacademy app, including myself. So I would take at least 2 to 3 free special classes every week. So you can join those and carry on with your learning completely free of cost without even getting the subscription. Plus, you can attend free quizzes like the one we have every Tuesday. So all these features you can simply unlock just after installing the Unacademy app. To unlock all these features, you can use my code RDLive. Okay, so that will help you unlock these features and see how it is on the app, how your studies would go. So it will give you an idea about how your plus experience is going to be. All right. And in any case, so hello, Vishnu Vardhan. How are you? Oh, Vishnu Vardhan is astrophysicist. Wow, that seems interesting. All right. So as I said, now, if finally after attending all those free classes, free sessions, if you really like, your experience with the Unacademy app, then you can go for the Plus subscription, and this is how you go ahead to get yourselves the Plus subscription. You'll need to go to the Plus section of the app and select your goal as IIT JEE and click on that Get Subscription button. The moment you do that, you will be redirected to the payment page where you will have a box which will say, "Do you have a code?" that is where you can use this code RD Live. That is my code, and this code will get you a 10% off on all year subscription fees. Now you can choose from two plans, which are Plus and Iconic, and you will realize the fees of these subscriptions has been kept already very competitive. So for the fees for all 12-month subscription comes to about 2,800 a month, and for that for 24-month subscription comes to about 2,100 a month. So trust me, the kind of quality education that you are getting, the kind of top educators from which or who you will be studying is definitely worth the pricing. Okay, any reputed offline institute would charge you anywhere between 4 times to even 10 times this fees, and people I know are paying much more than this for their school tuitions for class 6, 7. All right, so here on the Unacademy app, at these prices, you are getting the chance to study from the best educators, the best professionals in the industry who will guide you to your dream ranks and dream colleges. All right. So make sure you're getting use of that, making use of that. Okay. Then you will also realize when you click on proceed to pay, you are also given a lot of no cost EMI options. So all subscriptions of 6 months and above can be paid for in with the help of no cost EMI. So that will make sure that you don't feel the burden of these payments. Also, you can break this into any number of no cost EMIs that you feel like or you feel comfortable with. Now let's tell you a bit about the Iconic subscription, since this is a relatively new feature that the Unacademy is offering. So the Iconic subscription will actually take your IIT JEE preparation to the next level. And how does it do that? You will be allotted personal coaches. So from a team of experts, you will be allotted personal coaches who will personally guide you and mentor you throughout your IIT JEE journey. You will be attending regular IIT JEE workshops, receiving time to time expert guidelines, getting a study planner. Again, I think a huge bonus because a lot of students struggle with that, and regular test analysis sessions. Okay. So this kind of subscription is meant for those students who want more personalized attention and more personal guidance. Okay. Those can go for the Iconic subscription. Now you can even win this kind of subscription, test your knowledge and check your standing amongst your peers by taking part in the next Unacademy Combat event. So those of you who don't know this, this is the most competitive gamified IIT JEE battle. Okay, you can compete live in this, and if you do well, you stand a chance to win yourself some really cool rewards and prizes, which include a lot of gift vouchers and even year-long Unacademy Plus subscriptions. Now the next event is going to happen live on the 3rd of January. You can enroll now with the code RD Live and do well in that quiz. Not only you get to brag amongst your students, your friends, about how well you did, you also get to win some really cool prizes. Now these are the two new batches that have been launched on Unacademy Plus app. So Manzil batch for Target 2022 students and a Rank Booster batch for Target 2021 students. So you can enroll now if you are interested in that. Those of you who are following us on the JEE English channel of YouTube can connect with us on the Telegram app using this link. Okay, this will make sure that you're receiving all timely notifications of all the sessions and lectures happening on this very channel. Okay, all right. Why don't we get started with today's discussion then? So, hi Rajesh, how are you? An astrophysicist. Okay, so he has retracted a message. All right. Okay. So let's again get started with today's discussion. As I said, today we'll be talking about satellite motion. So in the last class, I told you the idea of binding energy and I told you how to calculate escape velocities. So now today we'll shift our focus to satellite motion. All right, so this is our discussion. So suppose you have a satellite which is revolving around the Earth in a radius of small r. Okay, and Earth has a mass of capital M and a radius of capital R. In the orbital speed can be related with the radius of the orbit as this. Okay, so the idea is simple. The idea is that if you think about this satellite, so what is the force that is causing the satellite motion? Okay, so the force is the force of gravity, right? This force of gravity would be providing you the centripetal force, which will enable the satellite to perform its circular motion in its orbit. So if I can write the equation, I know that F of gravity should be equal to m v naught square over r, right? And F of gravity I know is g, mass of Earth, mass of satellite, over a small r square, and this would be equal to m v naught square over r. When you solve this, this is the formula that you get. You get that v naught is equal to root g m over small r, where small r is the radius of the orbit. G is, of course, the universal gravitational constant, and capital M is the mass of Earth. So you will notice one thing, that this orbital velocity is simply related to the radius of the orbit. It does not depend on the mass of the satellite. You can have satellite of any mass. You can have the moon. You can have a tennis ball revolving in a certain radius. If the radius is same, they both will have to move with the same velocity or same speed rather. Okay, so remember this. This is a formula that we use very, very often. Very important formula. Okay. All right. Now, if we take a special case of that, so imagine if the radius of the satellite is close to the radius of the Earth. Okay, so most of your spy satellites are like that. Okay, so these are called near Earth satellites. So for near Earth satellites, you will realize that the orbital velocity would be root gr. Okay, please remember that. So this is escape velocity over root 2. You notice. So it is less than the escape velocity. That's why it's not escaping. Okay, and it is bound in its orbit and it is rotating. So this is a special case that we sometimes consider. Okay, you again do not really need to memorize this expression. You mainly need to memorize this one. All right, now let's move forward. And suppose now that I've related the orbital velocity with the radius of the orbit, now I can find the time period of revolution. So time period of revolution, I know if in one revolution the distance covered would be 2 pi r and it is being covered with a speed of v naught. So here for the sake of simplicity, we are assuming circular orbits, and again in your syllabus for JEE, we only consider the orbits to be circular. The analysis of elliptical orbits is slightly more complex, so we do not do that. So let's write a note here. In JEE syllabus, we only consider circular orbits. Okay. So we do not talk about elliptical orbits. In reality, the orbits would be elliptical, but the analysis of elliptical orbits is more slightly math extensive, and that is why it is slightly more difficult. So the analysis of circular orbits is definitely way more easy. Okay, so if you realize the time period of revolution would have been 2 pi small r over v naught. Now the value of v naught as calculated here can be substituted here, and that will give you this result. Okay, so this is the result that you have for time period. Again, you can memorize this. This is important. Okay, this is a very, very important result which you will need to remember. Okay. So now you realize that this also exhibits the third law of Kepler. You can see from here that T square is in fact directly proportional to R cube. Okay, that is small r, right? So that can also be seen. And now you can imagine another very interesting thing. So if we are talking about the satellites of Earth, then for every satellite of Earth, you realize that T square over R cube, how much will that be? That will be 4 pi square over g times mass of Earth, right? So all the satellites of Earth would have a fixed ratio of T square is to R cube. Similarly, can I say that all the satellites of Sun would again have a constant ratio, suppose, for all the planets, okay? So can I say also T square over R cube would have been equal to 4 pi r square over g times mass of Sun, okay, for satellites of Sun, or for planets, or planets are essentially satellites of Sun, right? So you realize this value had already been calculated by Kepler. Kepler had told us this value. So the moment Cavendish told us the value of G, the moment G was known, you realize we could estimate the mass of Sun. So you must have seen if you couldn't Google, you can Google and find the mass of Sun. So have you ever wondered how were we able to estimate the mass of Sun? How can I possibly estimate the mass of Sun? I mean, there is no experiment that I can perform on Sun, right? There is no experiment that I can perform on Sun and figure out the acceleration due to gravity on the surface of Sun and figure out the mass of Sun from there. So on Earth, we know. How did we figure out the mass of Earth? We knew the acceleration due to gravity, and we used that to estimate the mass of Earth, right? Now, turns out this mass of Sun was estimated by using the value that Kepler gave us, okay? And once I know the mass of sun, and from parallax method, I can also estimate the radius of sun. Once I know both those values, I can also estimate the value of acceleration due to gravitational pull at the surface of the sun. Also, you can Google and find those values also. So if you ever wondered, how people were able to estimate those values, now you know. Okay, it's all from Newton's law of gravitation. Okay, this is a universal law. There's a term universal attached to it. That means these equations work for any object. They will work for black holes. They work for stars. They work for sun. They work for Earth. Okay, so that's a very, very interesting thing. Now, again, here it has been iterated again that you will notice that t square directly proportional to r cube can be seen from the above equation. Now, there's a special kind of satellite which we call geostationary satellite. Now, what are geostationary satellites? So, geostationary satellites are special satellites for which the time period is 24 hours. So, if the time period of any satellite's revolution is 24 hours, you realize that satellite would have appeared stationary as seen from Earth. So, imagine if Earth is here, the satellite is here, if both have the same time period. So, what happens is that this satellite always remains above one position of the Earth, and from Earth it appears to be stationary. It will always appear vertically above this point. So, these are called geostationary satellites. These are very, very important for your communication systems. Suppose you are making a call in India, so you are maybe you are getting satellite TV, okay, dish TV in India. So maybe your broadcaster is somewhere in Mumbai, let's say, and let's say I am getting the signal here in Delhi. So the broadcaster will send a signal through the satellite dish. The satellite will transmit a signal to Delhi, but then I need that satellite in the space to always be above India only, right? If the two time periods are not synced, then the problem is the Earth will rotate with a different time period, and this guy will rotate with a different time period. So if it is not above my region, then it can't send me signals, right? So turns out if we did not have geostationary satellites, turns out you would have watched your satellite television maybe for a few hours a day, because only for a few hours a day the two satellite and the Earth would have synced, and only for that period you could have received the signal. Okay, the very reason that you can watch your satellite television 24 hours is because these satellites are geostationary. Okay, they always remain above you. Okay, so for the condition for that would be that the time period should be 24 hours. The time period is 24 hours. Now you can also estimate the radius of such geostationary satellites. So they are of huge importance in our daily life and our practical use. Okay, so that is why it is worth mentioning this. Now, apart from that, if you talk about the energy of a satellite, then you know that the satellite is revolving in a radius of small r. So at any time, the distance between the center of the Earth and the satellite is small r. So the potential energy of interaction of Earth and the satellite would be minus g mm over r, right? And since I know the orbital velocity, so I can also estimate the kinetic energy of the satellite. So it turns out the kinetic energy of the satellite comes out to be half g mm over r, which is positive half of the potential energy, right? So the total mechanical energy comes out to be minus of this. Okay, so again, these are very, very important equations, very, very important. Must remember these. So this one, again, this one, very, very important results. We will be using these a lot in our problem solving. So you must remember these. Okay. So you realize the total energy of the satellite is in fact coming to be negative. That is why it is bound to the gravitational field, right? We talked about this. If the total mechanical energy of any system of two bodies is negative, then that means they are bound to each other's gravitational field. All right. So we see here this is the satellite has a negative total energy, and that is called the binding energy of the satellite also, because if you provide a satellite this much of positive energy, then it can break free from the Earth's gravitational fields. Okay. So this is called the binding energy of the satellite. Again, please remember all these equations. These are very, very important, very, very easy to derive also, but these are so commonly used that we would like to memorize them. Okay. Hi Ethan, how are you? So my friend is a KVPY aspirant. Can he refer to these lectures? Yes, he can, of course. Of course. So in KVPY, there is nothing new except for the level of questions is slightly different. So that is more towards advanced and Olympiad. But if you are preparing well for advanced and Olympiads, then trust me, KVPY is already covered. Okay, that's only a subset. It lies somewhere around that range only. Okay. All right. So why don't we try a question then? Let's see. So this question says a geostationary satellite is orbiting the Earth at a height of 6 r above the surface of the Earth, where r is the radius of the Earth. You have to find the time period of another satellite at a distance of 3.5 r from the center of the Earth. Okay. Now, please note the language. This is where most of you people get it wrong. Here it says height of 6 r above the surface, and here it says at a distance of 3.5 r from the center of the Earth. Okay, so just remember that. That is where people make mistakes. Okay, Ethan says, sir, for mains, which chapter can be covered quickly and also give 4 to 8 marks? Okay. So in physics, the problem is that most of the questions, no, Ethan, they have mixed concepts. Okay, so it's slightly difficult. But let's say NLM is a great topic, but then you're not sure, how the questions are devised. Sometimes they don't ask questions directly from NLM anymore. Not much. They want to mix the ideas, because you realize they have to judge your entire knowledge of physics in 30 questions or 25 questions as is currently proposed. So how do they judge all the chapters in like 30 25 questions? They like to ask questions with mixed concepts. Okay. So as you are saying, 4 to 8 marks, I think a few things that you can be sure of is they will ask questions of thermodynamics. Now, thermodynamics, I think, is a must from class 11 topics. Okay, this is also a part of your chemistry syllabus, so definitely do this. Okay, it will take some time, but it will be worth it. For chemistry and physics combined, you will get around 10 marks questions from this. Okay, I think at least. Okay, so thermodynamics, I think is a must. Then I think work power, energy, and NLM. If you do this again, you are sorted for another 8 marks or so. Okay. Hi, JEE aspirant. How are you? For class 12th, I think AC and semiconductors would be small topics, which can be covered very quickly, and they generally ask at least, a couple of questions from that. So 4 to 8 marks sorted there also. And AC and semiconductors are very, very small topics. Okay. I think these are like 2, 3 topics which you can quickly cover, and almost be sure that you will get 8 marks questions from each. So there your 24 marks are probably sorted in physics just by these topics. Okay. All right. Anyhow, do not really rely on this, because we can only estimate. Okay, you never know in what shift, because there are going to be 4 papers and so many shifts. So it's not necessary that the person who's making the paper can always create a good balance, okay, of the topic coverage, Ethan, right? So that is why I don't like to be selective in my study. At least as a student, I never like to be selective in my study. You never know, yeah. They are making so many papers, so many papers. So in some papers, they may just forget to include some topics and maybe get more questions on other. Then maybe they can compensate that in another paper or something like that. So though this is what I have suggested, but don't think, okay, this is exactly what is going to happen. Okay, things may not turn out that way, and then you can't blame me. I can only tell you my estimate. But you never know, with so many papers, 4 papers in 4 months. In every month, you will have like 5 days of papers, 2 shifts. So 10 papers, 40 papers in total. So I'm not really sure if all those 40 papers would be perfectly balanced. Okay. And that is why you students are getting so many chances, right? So try and cover all the topics if possible. Okay. Otherwise, the important ones, the most important topics are definitely mechanics and electromagnetism. So those definitely form around, those 2 topics alone will form around 40% of the questions. Okay. Your mechanics, which is the major part of 11th plus electromagnetism. These are the most important topics from your entire syllabus. But again, these are huge topics. Huge topics. 40% syllabus they will cover. These two will cover 40% of syllabus. Okay. So I would want to tell you that please make sure that you are studying these. Apart from this, maybe again maybe something like solids you can maybe leave out, elasticity and solids. That's not very frequently asked. Even gravitation for that matter, since there is so much in electrostatics, that gravitation they don't like asking too many questions. Maybe one question only from gravitation may or may not be asked. Okay. So again, if I go into that kind of analysis, we will spend a lot of time, which I don't think is worth. Okay, you can rather spend that time in studying. Okay, and trust me, these are small topics, will not harm you that much. All right. So anybody figured out the answer of this? Anybody having answer of this one? Okay, so again, this is very easy, guys. I don't know what is taking so long. T square over r cube is constant. So you can say T1 square over R1 cube should be equal to T2 square over R2 cube. So you can say that T square would be equal to T1 square R2 over R1 whole cube. Or from here I can say T2 would be equal to T1 times R2 over R1 to the power of 3 by 2. Correct? 6 root 2 h 6 root 2 hours, is that? Oh, okay, let's see. So hello Vardhan Reddy, how are you? So very simple. T2 we had to calculate the height of the radius of the second satellite was 3.5 r. The radius of the geostationary satellite would actually be 7 r because this is the height. What I can say is that T2 would be T1. T1 is 24 hours into 1 by 2 to the power of 3 by 2 hours. Okay, so what you can say is this is 12 by root 2 hours, or yes, as AP rightly said, 6 root 2 hours. Okay, so absolutely correct, AP. Very well done. So Ethan says also, sir, one last question. If I don't know much about a topic, can I watch your quick review? Absolutely, that will always help. And one more thing. I don't know, Ethan, if you have watched my lecture on how to use options. How to use options in MCQs. Have you seen this video? This is something that will really help you in mains. In mains, a lot of questions can be answered just by using options. So at the end of the day, in the paper, if you don't have much idea, or you, because of the pressure, sometimes it happens, that people can't remember the formula. Oh, so watch that. I have told you some really amazing tricks of getting to your answers just by looking at the options without even knowing the concepts much. Just by, if you know some basics about a concept, and if you can pay close attention to your options, then you will get to your answer very easily. Okay. So watch that. That will help you in pressure situations. Okay. So let's say you have 10 minutes left and you have like 10 questions where you don't have any idea how to solve, or maybe you can't remember the formula, you are feeling the pressure of time. You can use these tricks, and within 10 minutes you will be able to find at least 5 answers. At least 5 answers just by using the options. So go through that, and that will be a great help. Okay. All right. Now let's move on to the next question. Okay. So the next question says, find out the minimum energy required to launch a satellite of mass small m from the surface of a planet of mass capital M and a radius r in a circular orbit of altitude 2r. Okay. So pay attention to the language. Pay attention to the language. It says find the minimum energy required to launch the satellite of mass m from this planet in a orbit of altitude 2r. Altitude 2r means small r. The radius of the orbit is going to be 3r. Okay. So that is something that you have to find. So let me just quickly solve this. This is very simple to solve. Maybe you guys can give it a try also. Okay. Maybe I'll wait for you guys to try this. Till then, I'll help myself with some water. Okay. So others also can watch this lecture. I don't know how you don't know about this. This is just to help you with those kind of things. Okay, watch this. This is going to help you a lot in your competitive exams, especially in mains, and also NEET for that matter. In NEET and mains, these tricks work a lot. They will not work very well in advance because in advance they are very smart about making their options. Okay. But definitely in mains and NEET. In mains, at least 10% of the problems can be solved simply by using options. In my experience, I've seen that in every paper of physics that we used to solve, and we used to make the solution, back when I was in my offline setup. So we had to, before it became online, so we would come up with the answer key, right? So trust me, every time we were making answer keys, at least 3 to 4 questions in physics every year, I would just get the answer by looking at the options only. So we used to have this hurry, to get out the solutions as soon as possible, so that because students would be waiting. Trust me, I myself still use these techniques, okay, and they work. All right, coming back to this question. So let's say, once the satellite is in the orbit, what is the total mechanical energy? Total mechanical energy in the orbit, that I know, is minus half g m over r. Correct? I hope you remember the formula. Now, small r would be 3r. The radius of my orbit is equal to 3r because the altitude has been told to me as 2r. Correct? So I know once this satellite is in the orbit, its total mechanical energy would be minus gm over 6r. Now, what is its energy at the surface? So energy at its surface, so energy initial at surface. So again, let's talk about total mechanical energy only. At the surface, it will have a potential energy which would be minus gmm over r, and let's say it has no kinetic energy because we haven't launched the satellite yet. So the total energy would be this. Okay, so how much energy is required to send this satellite into this orbit? So energy required is difference of the energy, right? Whatever is the difference of the energy, final minus initial, so I can say it will be minus gmm by 6r plus gmm over r. What you realize is the energy required is 5 by 6 gmm over r. You will have to provide this much energy to the satellite in order to make it reach its orbit. Okay. Again, very simple. Just find the energy in the orbit, find the energy at the surface, find the difference. Okay, and that will help you get the answer. Okay, Ananya Prakash says, sir, what is the difference between the mains and the advanced level other than the number of questions and that chapters are mixed to form one questions for the topics? Okay, do I need to even go beyond what's in HCV? Yes, Ananya, you will. For mains, you don't. For mains, you don't, but for advanced, you will. For advanced, you will. For advanced, you will. So the difference is, let's say about a situation. Okay, so mains will present you a simpler situation to analyze, and advanced will present you a more complex situation to analyze. Okay, let's take an example. Okay, let's say if you can just compare these two. Okay, so imagine one is let's say analysis of a body moving in a circle on a horizontal table. Okay, and another is this moving in a vertical plane. Okay, so you realize the analysis of this situation is more difficult, right? And if I ask you to find the tensions at different point, so if I ask you to find the tension here, mv square by r. But here, if I tell you that At some point, you have to find the tension. Then you realize the analysis would be difficult. So imagine this is horizontal situation, which is easier to analyze, correct? And again, another circular motion in vertical plane, which is more difficult to analyze. So that's the difference between mains and advanced level problems. Okay, mains will present you simpler situations which are easier to analyze, and advanced presents you more complex situations which are definitely more difficult to analyze. Now, as far as the level of difficulty in mains is concerned, HCV is more than enough. Nothing beyond HCV is usually asked. Okay, HCV is good enough for mains. Okay, how about advanced? Advanced, sometimes HCV is not enough. Okay, so for these kind of situations, HCV will not be enough because the situations may be too complex. Okay, so the only my teacher said I need to read first year BSc books. Okay, no. I don't think so. Okay, first year BSc books. No, not really. Not really. No, that's not the idea. I don't know why your teacher would say something like that. So I mean, you may need to read those first year BSc books. Maybe if you're planning to teach. Okay, if you plan to teach for JEE, not for taking the JEE. No, that's not important. Okay, I never did it as a student also. What you need is clarity of concepts. That's about it. Because see, even though situations may be complex, which you want to analyze, but the ideas and the fundamentals are still the same. Okay, JEE will never ask you something which is beyond your class 11th and 12th syllabus. Okay, that's not what they do. That's not what they do. That's why you don't need to read first year BSc books. Okay, that is ridiculous. Any question in JEE will not have. Okay, sometimes they do. Ask those questions. Only once in a while they have. I think that too by mistake they put it because they usually give them as bonuses or 2-3 options correct then. Okay, but all you need to do is clarity of concept plus practice. All you need is practice of tackling difficult situations. Okay, if you've practiced your tougher problems, then trust me, you are sorted. Okay, you don't need to study any BSc books. Okay, I can definitely claim that with 100% certainty. Okay, no question of JEE will ever require any knowledge of concepts beyond your 11th and 12th syllabus. Okay, it's just that you need to have a more in-depth knowledge though, and a more in-depth understanding and grasp of the concepts. Okay, that's it. Only two things required. First, you must be really clear about your concepts. Now, when I say really clear about your concepts, so every concept will have its limitations and its scope. So you will have to think beyond the regular scope of problems that you are used to. Okay, as I said, your NCRT does not present you challenging enough problems. So if you solve your NCRT, you will realize you can solve those easily because the level of difficulty or analysis required to solve those problems is easier. Now, when you move from NCRT to HCV, you realize HCV problems appear slightly tougher, but they are based on the same concepts, right? The fundamentals are same. You can take one chapter, let's say Newton's laws. You can solve Newton's laws problems from NCRT. You can solve Newton's laws problems from HCV. Now HCV seems tougher, okay, though it is the same concepts. Just because the situations given to you for analysis are more difficult, they require more depth understanding, in-depth understanding. Okay, and JEE Advanced is slightly more difficult than this. Not by much, only slightly. Okay, let's say. Okay, if HCV questions would be roughly around, let's say 80% of the difficulty level of, or 75% difficulty level definitely of JEE Advanced. Okay, but BSc books, no, those you don't. Okay, even the maths that you will be using in solving your physics is not that much. So after HCV, Irdov is needed or PYQs are enough. Okay, so Irdov is definitely a good idea if you're aiming for one of those top ranks. Okay, so I personally always suggest that if you're aiming for top ranks, then Irdov would be needed. Okay, so let's say if you're aiming for top 2000 ranks also, top 1000 to 2000 ranks also. Then you need Erudov. Okay, Erudov is needed because you need to expand your thinking horizons. See, the kind of difficult problems that you have in Erudov, what they help you do is they help you expand your, thinking ability. Okay. Now you're not just thinking about simple situations. You are trying to analyze more difficult situations. Also, apply your brain as to what works there. Okay. Yes. Otherwise, if you are aiming for maybe even a top 10,000 rank, up to 10,000, between somewhere between 5,000 and 10,000 rank, I think HCV and PYQs would be sufficient. But just do more practice than that. Okay. So for this kind of rank, HCV plus PYQs is definitely sufficient, okay, to score, to be able to solve those many problems. But you will also need practice because it's a competition. So you will need practice to work on your concept more. Okay. Again, because of the competitive nature of the exam, you will want to do better than that because a lot of students would be doing this. Okay, so you will need some extra also, something extra. Okay, maybe not but at least maybe one or two more books with a decent level. Okay, that is my advice. All right. So here we solved this one. I hope everybody follows this. I want to try IIT Aerospace 700 to 1200. Then you should be solving Aerodo. Then you should be solving Aerodo. No problem at all. That's perfectly all right, kid. That is why we are here, no teachers. We are here to guide you. Okay. If you're aiming for that kind of rank, then to be on the safer side, you would want to get a top 1000 rank, right? For top 1000 rank, trust me, you need to solve Erudov. Okay, I've had students who solved Erudov and still landed up with around last year. I think I had a student who had solved quite a bit of Erudov, and he still landed with a 1400 rank only. Okay, so not saying this to discourage you, but the point is the competition is so high. The competition is so high because everybody is doing that. A lot of students are solving Erudov also. So that is why that's a must. If you don't do it, you are already at a disadvantage. Okay. But doing that also will not guarantee that you will get a top 1000 rank. Okay. Again, as I said, you will need to do something extra. Get more practice, get faster with your problem solving, and balance your three subjects definitely. I think physics would be okay sorted for a top 1000 rank. If you have solved HCV and Erudov and PYQ, that should be good enough. Okay. Rest, let's hope you can balance all the three subjects and work on your speed and accuracy. Okay, that comes from practice. All right. So it's a combination of a lot of factors, because this is such a competitive exam. You can't just focus on maybe one or two aspects of it. Okay. All right. So here is another practice problem. So this one says an artificial satellite is moving in a circular orbit around the Earth with a speed equal to half the magnitude of escape velocity. Okay. Now you have to find the height of the satellite above the Earth's surface, and if the satellite is stopped suddenly in its orbit and allowed to free fall on Earth, find the speed with which it hits the surface of Earth. Okay. So try this. Try this. Let's see if you've been paying attention. If you think how you can solve this. So what has been given to you? You have been told the orbital velocity. We already know how to relate orbital velocity to the radius, right? Jay Patel says, "Sir, is it too late to take plus subscription for JEE 2021?" Okay, so you realize, Jay Patel, there are all sorts of subscriptions. So there are even 6 month subscriptions. You can go for a 6 month subscription. Okay. Now you realize even in JEE 2021, the advanced for mains only you have four months, right? Feb, March, April, May. So you still have roughly 4 to 5 months also for the last two papers, right? Plus for advance, you still have around 6 months. So I think you can still go for a plus subscription. You have all sorts of crash courses there running. They will definitely help you. So it's never too late for anything. Okay. So as I said, it's never too late to get some extra help. Okay, you still have enough time. Yes, if you ask me that tomorrow is my last. Okay. If tomorrow is my last, JEE mains paper, then yes, I would have said it's late. But right now you have a lot of time, and I think you can create a significant difference in that time. So I don't think it's late at all. Okay, all right. You can go for a 6 month subscription. Okay, and trust me, you have so many crash courses and special classes and practice sessions happening that will definitely help you with improving your rank. Okay, so how about this question? So let's see. You have to find the height. You have been told the velocity. You know the relation. Okay, so how do I get it? Very, very simple. We know V naught is root of Gm over R. Okay, this is all you need to remember. Okay, that is it. So you know V naught is escape velocity by 2. So escape velocity was root 2 Gr or Gm over R. Okay, so into 1 by 2. So what I can say is, so Gm over 2R would be equal to Gm over R. So obviously small r, sorry, what I was wondering. Small r. So what you realize is small r equals 2R. What is the height? Please note the word height of the satellite above the Earth's surface. Height h is r. So this satellite is at a height of radius of Earth. Okay. Hi Shivam, how are you? Okay. So again, be always very careful about the wording of your question. Take your time while reading the question. Okay, that is where I made the mistake in my JEE. I did not take my time to read the question. I was in such a hurry. Now I tell students, take that time to read your questions. It is worth it. It's better to read it correctly and give the correct answer rather than being in a hurry and eventually reporting the wrong answer. Okay. Because trust me, 2R would have been in the options if there were options. R and 2R both would have been in the options. So if you hadn't read it correctly, that the height is to be reported, many of you would have marked 2R and got something wrong which you knew. Okay. Next, it says if the satellite is suddenly stopped in its orbit and allowed for a free fall towards the Earth, then find the speed with which it hits the surface of the Earth. That is again very, very easy to understand. So initially, it is at a distance of 2R. All you need to do is apply energy conservation. If this stops, its kinetic energy is zero. It only has a potential energy. So U initial would have been minus G M M over 2R, correct? A initial would be zero. When it reaches the Earth's surface, U final would be minus G M M over R. And let's say it reaches with some velocity V. It hits the surface of the Earth with some speed V. So K final would be half mv square. Now all you need to do is apply energy conservation and find the value of that field. Okay, that is how you would have done it. Now this is another interesting thing which mains people sometimes may ask. So this is something that you just need to know. Okay, so you have been told here the velocities of projectiles and their trajectories. So if the velocity of projection is less than escape velocity by root 2, okay, then the projectile does not revolve around the Earth and it will fall back onto the surface of the Earth. So this is what will happen. If you project something with a velocity less than v by root 2, it will always come back and fall on Earth. Okay, that's the first case. Again, this you just need to memorize because this is something that most people might ask. Not important for advanced at all. Advanced does not ask you something which you just have to memorize, but means people sometimes may ask. Okay. Now, if the speed of projection is VE by root 2, where V is the escape velocity, then the projectile revolves around the Earth in a near circular orbit. So this is the orbit that you have for here. Okay, so let's create these. This is showing you this situation. This is showing you this situation. Now, if the velocity of projection currently working on advice you gave day before yesterday, good. Good. Keep working and trust me. Sometimes it just takes time, time for problems to get sorted. But eventually, if you keep working towards sorting your problems, they will get sorted out. Okay, don't give up. Just be positive and keep working for it. Okay. Similarly, if the velocity of projection is between the escape velocity and v by root 2, then you will realize elliptical orbit is taken. Okay, maybe we can use a different color. Yes, here. in this particular case, you will see the satellite taking an elliptical orbit. Now, interestingly enough, if something is launched with V by 2, then the satellite will take a parabolic orbit to infinity. And if you launch something with a speed greater than escape velocity, then the satellite is seen to take a hyperbolic path to. Okay, so this is what you just need to know. Just for your knowledge, you just need to know these. Okay. Again, you don't even need to know the reason of these. Okay, that is not going to be asked because that kind of analysis again is not in your syllabus. So advance will not ask you this. Okay, this is important only for mains or maybe astronomy Olympiad. Beyond that, not much use. Nobody will ask you this in boards. Nobody will ask you this in advance. Maybe in mains theme. Okay. If you want, you can skip it altogether. It doesn't really matter because it's not even necessary that they will ask you something about this. All right, Shivam. First, now let's try one question. Now this is a tricky question. I want you to think about this. Now you've been told in this question, an object is launched from the surface of the Earth with an initial speed of escape velocity by 2. Okay. So where does this lie? This lies in this range, right? So this will come back to Earth. Okay, you know that, right? So, and you have launched it in two ways. In one way, you are launching it vertically upwards, and in the second manner, you are launching it at an angle of 30 degrees with the horizontal. Now, in both the cases, you have to find the maximum height achieved by the particle. Okay, so think about this. Think about this. This is a very, very interesting situation. So, same speed is given to two particles, but in two different manners. Okay, you're projecting one guy vertically upwards and one guy like this at an angle of 30 degrees with the horizontal. Now you have to find the maximum heights achieved by both of them. Both of them, after achieving some maximum height, would come back to Earth. Okay, so this will show a trajectory like this. So this would be the maximum height. Let's call this H1. How about this? How will this other particle go? This will have a very interesting path. This would have gone like this and come back here. So this would have been H2. Okay, so you have to find the relation between H1 and H2, or find H1 and H2 separately. Okay, so try this. This is interesting. Finding H1 is very, very easy. That's something that you can easily do. Okay, just apply energy conservation. That's about it. Okay. So part one, let's solve part one first. Part one says if it is projected vertically upwards. So in part way, I know initial potential energy is minus Gm m over r. Now initial kinetic energy, what will that be? That will be half m into v square by 4. So this comes out to be 1 by 8, and v was gm 2 times m over r. Okay, escape velocity was root 2 gm over r, so square of that would be this. So final kinetic energy is coming out to be gm m over 4r, right? So finally at the highest point, you only have u. So u final would be minus gm m over r plus h, where h is the height, r plus h1, and what is the kinetic energy final? Kinetic energy is going to be 0. So from energy conservation, what I can say is that the total energy should be constant. So I can add these two up. I can say minus gmm over r plus gmm over 4r to be equal to minus gmm over r plus h1. Right. So you can get rid of these. And what you realize is that this will be minus 3 by 4r to be equal to 1 over r plus h1. So what you realize is that here you will get the minus also gets cancelled. 3r equals 3h1, and this is, so h1 you are getting as r by 3. Okay, this is what you will get your h1 as. right? How about H2? In the second case, what will be the maximum height? So that is going to be something interesting. Let's add one page. Now, the problem here is, again, I can apply energy conservation, right? So yes, I can definitely apply energy conservation, but I have another issue there. Now, the issue that I have is, so let's say this will be surface from where the Earth, the particle was projected, and it was projected at some angle of 30 degrees with the horizontal, right? So the path that this would have taken, this would have taken would have been, try and use lighter colors here, would have been something like this. Now, if here this is R, this is H2. So I have one problem only. One problem that I have is I know the initial energies here. Okay, so initially here, what are the energies I know here? The kinetic is not zero. Okay, here the speed was V naught, correct? The speed was V naught. Now here there will be some V because it won't be at rest. So if I can find that V, then I can apply energy conservation. Okay. So again, this is an advanced level problem. Okay, right there. Now, mains will never ask you about this. Mains would have asked you this, the previous one. So that's the difference between mains and advanced. Okay. Now, what I can say is that I know about my initial potential energy. Okay, U initial. What is the initial potential energy? It would be minus Gm m over r. Okay, I also know about my initial kinetic energy. It would have been the same as the previous one because the speed is same, right? It would have been Gm m over 4r, correct? Now, how about my final potential energy? U final would have been minus Gm m over r plus h2, and I would have had some k final, which would have been half mv square. And now the entire problem is figuring out this value of v. That is the entire issue. How do I figure out the value of this v? So for that, I will use a trick. Now, if I look at the motion of the satellite, now pay attention to this. This is interesting. For its entire journey, it will feel the force of gravitation. Right? The force of gravitation is always directed towards the center of the Earth. Okay. So can I say that the angular momentum of these projectile will never change with respect to the center of the Earth? That is the trick that you want to use. I can say that since during the entire motion of the satellite or of the projectile, the force of gravity on it always points towards the center of the Earth. So what I can say is that the angular momentum of the projectile above the center of the Earth must be constant. Okay, so therefore, the angular momentum of the projectile about the center of Earth is constant. Okay. So now I can find the initial angular momentum. Initial angular momentum of the particle would have been m v naught times cos of 30 times r. Okay. I hope you can see that. For this velocity, I can break this into two components. So I can break this into two components. Let's take like this. So one component like this and one component like this. Only this component will contribute to the angular momentum, and that would be v naught cos 30, right? The angular momentum would be mv naught cos 30 times r, because the distance from the center of the earth is r at here. At the highest point, another interesting thing is that this entire velocity would be perpendicular to this. It would be perpendicular to the line joining this, right? At the highest point, you just need to remember that. So at the highest point, final angular momentum turns out, well, final of P would be mv times r plus h2. You just equate these two, and from there you will find your answers. Therefore, I can say that P would be equal to P naught cos 30 r over r plus h. Now, all you need to do is substitute this value over here. This value we will substitute. Let's mark this with some color. This value I will substitute over here. And then apply energy conservation, and I'll get my answer. Okay. So that is how you would have approached this problem. Okay, I hope you guys can see that. Okay, just go through this. We saw the situation of motion, and then we wrote the initial potential energy, initial kinetic energy, which is easy to see. The only issue is I don't know about the velocity at the highest point. If I can figure out the speed at the highest point, then I can write the final kinetic energy. I know the final potential energy. I don't know the final kinetic energy. In the previous case, when it is launched vertically upwards, then it is zero. Right, that is easy to see. But here it will not be zero, and the speed has to be figured out by using the conservation of angular momentum. So this is a slightly tricky situation. This is the difference between mains and advanced. Okay, part A was a mains level question. Part B is an advanced level question. Okay. So anyhow, now you know how to solve both. Okay, you should not be worried. All right. So that brings me to the end of our discussion for the day. And before I leave you guys, let me remind you that you should be getting your plus subscriptions if you haven't gotten them already. And this is how you do it. You go to the plus section of your app, you select your goal as IIT JEE, and you click on that get subscription button. Now, when redirected to the payment page, do not forget to use this code RD Live. Okay, this code will give you a 10% off on all your subscription fees. All right. Now you can choose from two kinds of subscription fees, plus and iconic, and you can choose a payment plan which suits you. You can break these payments also into no cost CMIs. Okay, for so that you don't feel the burden of these payments. Okay. Now, those of you who don't know what iconic subscriptions are, iconic subscription is something that will take your IIT JEE preparation to the next level. And by allotting you personal coaches, you will be allotted personal coaches from a team of experts. You will be you will be attending regular IIT JEE workshops also. You will be getting expert guidelines from time to time. You will be getting a study planner, and you will have regular test analysis sessions. Okay, so those are the extra features that you are getting apart from the plus features. All right. Now, another great way of testing your preparation, seeing where you stand amongst your peers, and winning yourself the Unacademy subscriptions, plus subscriptions, and a lot of other prizes is by taking part in the Unacademy Combat. The next event is going to happen live on the 3rd of January. Make sure that you're taking part in that. You can enroll now using code RDLife. Do well and win yourself some really cool prizes. Now, these are two new batches which have recently been launched on the Unacademy Plus, so students can quickly enroll in them if they want. Okay. Now, if you like today's video, then don't forget to press the like button and share it with as many people as you can. So this is quality content being provided absolutely free of cost to you by Unacademy. Unacademy realizes that not all students can afford those subscriptions. So we are trying to make this knowledge available to all students without having to, pay for anything. Right, so it is your duty, those of you who are here, who are benefiting out of this, make sure that your friends and people who need this also, other people who need this also get this. Okay, so just spread the love, and of course, give some love back by hitting that like button. Spread the love by sharing with other people and other friends. If you're new to the channel, don't forget to subscribe and hit the bell icon to keep receiving notifications of all the lectures and sessions happening here. The PDF of all the slides used in today's lecture would be available for download very, very soon. Those of you who are following us on the JEE English channel of YouTube, remember to connect with us on the Telegram app using this link. Okay. Now, before I leave you one final time, this is the code RD Live. This is my code. So if you like my lectures, if you'd like to join my courses on Plus, And if you'd like me to guide you through your IIT journey, then you can get your subscriptions using this code. And this code, of course, will not only give you all the benefits of the plus, will also give you a 10% off. All right. So I will see you next in the next week's class. Okay. Oh, by the way, I think that's going to be after 1st of Jan, right? So happy New Year from my side to all you guys of class 11, because next session with you guys would be in 2021 now. All right. So I will see you then. Until then, you guys keep studying hard, keep practicing, and take good care of yourselves. Bye.